And now it's time for us to talk about the incorrect uses of the distributive property. Remember that we're using the distributive property incorrectly if we are not distributing the operation of multiplication or division over the operation of addition or subtraction. Let's take a look at the first example here. We have the expression 5 divided by the quantity of 3n plus 1. We separate it into 5 over 3n plus 5 over 1. And of course, 5 divided by 1 can be simplified as 5. We have addition, we have division. Is this distribution allowed? Well, let's think about this very carefully. When we're distributing division over addition, what we have is we are adding two numbers, we are dividing by something, and we take the number that we are dividing by, and we distribute that division by C into each term, right? So we have, in a sense, A divided by C plus B divided by C. Here, we didn't take the number we're dividing by, which is 3n plus 1, and distribute it into a bunch of things that we are adding, right? Here, we're not dividing a sum by a number, we're dividing a number by a sum. And so this use of the distributive property is not allowed. If we had an expression 3n plus 1 over 5, then yes, you could say the answer is 3n over 5 plus 1 over 5. It does not work in reverse. And by the way, it's not very difficult for us to just plug in a number for n and see that the expression that we have on the left will not match the result that we get. If I, for example, let n equal 1, the expression on the left will be 5 divided by 3 times 1 plus 1, which is 3 plus 1 is 4, is 5 over 4. While if I take the expression on the right and I plug in 1, I will have 5 over 3 times 1 plus 5. Well, that's 5/3 plus 5, which is 20 over 3, right? 5 plus 15. Definitely 20 over 3 is not the same as 4 over 5. So, by the way, if you feel like I've gone through the fractions part here a little bit too fast, you can pause the video and attempt to add 5 over 3 plus 5 over 1 on your own. Also, in your textbook, the very first chapter is the review chapter, and one of the reviews is on fractions. You may want to look at that if you're not quite sure how to add 5/3 and 5 over 1. Okay, the other incorrect use of the distributive property is given here, and I mentioned it a little bit in an earlier video. Here we have y plus 3 squared equals y squared plus 3 squared. In other words, the exponent was distributed into each number that we added, and then 3 squared, of course, turns into 9. But raising to a power is not multiplying or dividing. You are not allowed to distribute exponents over addition or subtraction. And again, you can check whether this is true if you just let y equals some number. Let's make it simple and say y equals 1 again. The left expression will be 1 plus 3 to the second power. 1 plus 3 is 4, and 4 to the second power, 4 times 4 is 16. While on the other side, if y equals 1, I have 1 squared plus 9. 1 squared is 1, plus 9 is 10. These expressions are not equal, and so you can see that the distribution was not done correctly. And at any point when you use a distributive property, or really anything else in algebra, and you're not sure if your variable expression is correct, you can just see, did you simplify correctly? Is it equal to the one you started with? Plug in a number for your variable, see if these two expressions are equal. If they are, then you're probably right, and if not, then obviously a mistake was made. All right, well, this was the last video of the first module. You are now ready to do your first homework assignment. Good luck.